Let's take a look at the proper procedures for accurately tightening a bolt using a micrometer or clicker-style torque wrench. While there are other types of torque meters, such as the deflecting beam, the dial indicator, and even a new generation of electronic models, by far the most common wrench is the reliable clicker. Wrenches come in many lengths and drive sizes, corresponding to lower or higher torque ranges. But regardless of the manufacturer or model, they all operate in basically the same way. A spring in the handle forces a pin or ball into the teeth of a gear connected to the square drive of the wrench. The higher the spring tension, the harder it is to displace the pin from one gear tooth to the next as the wrench is turned. The snap of the pin jumping the gear produces the characteristic click, indicating that the target torque has been reached. This is a popular brand of ratcheting head wrench, 18 inches long with a half-inch square drive and a torque range of 30 to 150 foot-pounds, or in metric terms, 40 to 200 Newton-meters. Mechanical torque wrenches such as this one are typically calibrated to an accuracy of plus or minus 3% in the clockwise or tightening direction. Each tool should come with its calibration certificate, which should be regularly re-verified by a qualified technician according to your accuracy requirements and frequency of use. Torque wrenches are precision tools and must be handled and used with care if they are to stay accurate. Don't drop or bang them, or they will need recalibration. They should normally not be used to break loose nuts or bolts. That's what a standard ratchet or socket tool is for. Overstressing during breakout will damage the mechanism. It goes without saying that an extension or cheater pipe should never be used with a torque wrench. There are two micrometer scales on the barrel of the wrench. On one side, the scale is in foot-pounds, and on the other side, it reads in Newton-meters. We will concentrate on the foot-pound side during this video, but the procedure is the same in metric units. Note that there is a vertical center line with graduated horizontal marks at 10 foot-pound increments. A scale at the edge of the adjusting collar measures in 1 foot-pound units. The wrench should have been stored at its lowest mark setting so as not to weaken the spring. Return it to that lowest value before you return it to storage. This particular model unlocks for adjustment by pulling outward on the locking ring at the base of the handle. Rotate the handle clockwise to increase the torque or counterclockwise to decrease the value. For consistency's sake, we always set our torque value from lower to higher because that is the way the tool was calibrated. Put on your personal protective equipment, which should include as a minimum safety glasses, gloves, and steel-toed shoes. Remember, nothing is as important as your safety. Before beginning measured work, the wrench should be exercised by running its torque setting into the top half of its range and cycling it on a bolt several times in each direction. Let's suppose that we need to apply 65 foot-pounds of torque to this 1 1/4 inch stud and 2-inch nut. Rotate the handle clockwise until its edge lines up with the 60 foot-pound horizontal line. Then continue clockwise until the 5 is on that center line. We have now set 60 plus 5, or 65 foot-pounds, as the limit value. Check your socket for condition and correct size. Place the socket onto the drive. Engage the nut with the wrench, preferably in a position to your right at about 90 degrees, so that you can pull, not push, on the wrench. Torque wrenches should be pulled only at the middle of the handle, not pushed, and the pull must be slow and steady, in the plane of the wrench. No jerks allowed. There is a common myth that the wrench will always return the same torque regardless of how it is turned. This is not true. Here is our demo wrench in a calibration bench adjusted for 65 foot-pounds. Proper pulling of the wrench reads right where it should. But look what happens if we jerk the tool or if we pull at an upward angle. The operator has as much to do with a correct reading as the wrench. Pull the wrench slowly until you hear a click. It is not necessary or advisable to pull it a second time. Relax your pull, remove the wrench, and proceed to the next bolt. If you are done with the wrench, remove the socket, wipe it down, and reset it to the lowest torque setting and return it to its case. Just a comment before we go. Remember that torque is not the same thing as bolt preload. Factors such as different lubrication or thread conditions may make one bolt far tighter on the joint than another, regardless of how accurately they were torqued.